Hello everyone, this is Meghasham Raju, Assistant Professor, Engineering College Bikaner, Mechanical Department. Today I'll be discussing about basics of metrology and measurement. Already we have dealt with these basics, but to continue with the flow, I'm just discussing the important topics in this subject. So before continuing with the e-lecture, let me ask you a question. What do you understand by metrology and measurement? Take down a notes and write down a few lines about metrology and measurement. So the terminology metrology will be daily coming in your life, knowingly or unknowingly, and the term measurement will be using in every field, irrespective of technology. You will be using this measurement term everywhere. Either it can be in science, engineering, biology, everywhere you will be using this terminology. So coming with the definition of the metrology, which is nothing but the study of the measurement. It is of utmost importance to measure different types of parameters of physical variables and quantify each of them with a specific unit. So you need to measure, and by measuring you need to give a particular unit to that. That is nothing but an process of measuring is nothing but an metrology. Thus measurement is an act of assigning accurate and precision value to an physical. Whatever you are measuring, you need to assign a particular accuracy and the precision to that value. That is nothing but a measurement. So by seeing this terminology, let me explain you what is meant by accuracy and precision. So before continuing, why can't you just tell me, why can't you just write in your notes what is meant by accuracy and precision? So in an layman terminology, accuracy is nothing but a deviation from a particular value, or a deviation from a particular target is nothing but an accuracy. Coming to the precision, if you are getting an consistent values every time for an measured value, then that is nothing but an precision. Let me give one example. If I just want to measure temperature, my desired, using some thermometer, my desired value is 25 degrees Celsius. But if I get first time with the measurement, if I get at 28 degrees, then I am not getting the accurate value. For the second time, if I am getting an 22 degrees, now I am having an error of +3 in the first case and -3 in the second case. Let me remind you, the positive error and the negative error, even though here the same, but they won't be cancelling each other. How I will be discussing the further classes. Let me tell you what meant by the precision. Now, by chance, if the second case also I am getting an value of 28 degrees. First case I got 28 degrees, second case I got 28 degrees instead of measurement of the desired value 25 degrees. So now I can conclude that the instrument is precise, but it is not accurate, because I am getting the same value twice with the same input, but I didn't reach my desired value. So now we can define the accuracy is the degree of agreement of the measured dimension with its true magnitude. It can also be defined as how much deviation differs from the true value or as the nearness of the measured value to its true value. Let me tell you what is meant by a true value. True value is nothing but a mean infinite number of mean values of the measured quantity is nothing but a true value. Precision is the degree of repetitiveness of the measuring process. That's what I have told you. Precision refers to the consistent reproducibility of a measured value. So this diagram clearly represents what is the difference between the accuracy and precision. In the first figure, you can see that I am getting an precise value, but I am not getting an accurate value. If my target is the intersection points of the plus vertical and horizontal line, but I am getting repeated values at the left in the above second quadrant. You can see the above second quadrant. But in the second figure, you can see that I am getting an accurate values but not a precise value. In the third figure, it is clearly representing I am getting accurate as well as an precise values because my true value will be at the intersection point of the horizontal and vertical line. But little bit of error is considered here. Little bit of error, you can just ignore it. In the fourth figure, you can tell that it is neither precise nor accurate. Coming to the error is nothing but how much you are deviating with the true value. The difference between the true value and the mean value of the set of reading on the same component is termed as an error. As I already told you, the true value is nothing but an infinite mean values of the measured value is nothing but an true value. In fact, the true value for any instrument, the true value will never be achieved because the uncertainty will never tends to be 0. That is the reason here we have considered in the true value an infinite number of the measured mean values. Anyhow, error is nothing but Vm minus Vt, where Vm is nothing but a measured value and Vt is the true value. So generally the error is measured in terms of an percentage. So to have the relativity, that is the reason percentage error is defined as error divided by the true value into 100. So now I'll be explaining you what are the elements of the measurement. Let me explain with some example. Take the example of the temperature or length. Take the example of a length. So the measurand here, the measurand will be the length and the reference. Reference is nothing but the standard value. Either it can be in meters, centimeters, millimeters, whatever standard values you know. You have to be compare the required length with the standard value, then the output what you will be getting is nothing but the measured quantity. So here it will be explained like this. The three basic elements of measurements are measurand, in which it is a physical quantity such as length, weight and angle, and the comparator is nothing but a reference value with the standard value will be calling it as a comparator. And finally, the physical quantity what you are getting is nothing but a measured quantity. Okay guys, at this point I just want to stop this lecture, and in the next lectures I'll be continuing with the third chapter and the third unit with linear measuring instruments like vernier caliper. I'll be discussing all these instruments, and in the further classes I'll be continuing with the third and fourth chapters. Thank you for listening my lecture.